Hello and welcome to another one of these ADD videos. Today we're going to look at the definition of the derivative. The definition of the derivative is something that is just basically a formula, a limit formula. But let's talk about what a derivative is first. When you think of derivatives, you should think of rates of change. Slope is a rate of change. Slope is a rate of change, and in this case, the slope we're talking about, rise over run, change of y over change of x, is going to be the slope of the tangent line. Remember, the tangent line touches your function at one point and one point only. And there are various uses of knowing what the slope is of your tangent line. It can give you the instantaneous rate of change at that point, for instance, which is down here somewhere. Derivatives can also be used to find the change in one variable if you're given that value of the other variables changed by a specified amount. Okay, and you can use it to predict how much change in output would occur if you changed the number of labor hours or something like that. Derivatives can also be used to estimate error, whether it's propagated error, whether it's relative error or percent error. You can use derivatives to approximate it. Also, we can use derivatives to approximate numerical values. Like if I wanted the square root of 17 or 15, I can use derivatives to do this with a high degree of accuracy. You'd be surprised. Derivatives also can be used to look at slopes of tangent lines, as we said, but over ranges of numbers. We'll find things called critical points and test them to see if they're maxes or mins, determine where the peaks and the troughs occur in your graph, and discuss concavity. We'll also look at instantaneous. I discussed that earlier, the tangent line slope at a specific value. And finally, related rates, we will look at the use of derivatives to look at rates of change over time. All right? So this is the big picture of derivatives. We're going to see this over time the next months or so in your class. So don't panic with all this here. I just wanted to introduce you of when you should think of derivatives. All right? So what is the actual formula, though? What will I need to use? So this formula is the limit as h approaches 0 of this difference quotient. There are many different difference quotient. You could have had a bunch of stuff up here, but this is the specific one used for the definition of the derivative. And basically, when you have f of x plus h, that means take whatever your function is and plug in an x plus h everywhere you see an x. Right? If it was a number, you'd plug in, let's say if it was f of 2, you'd plug in a 2 everywhere there was an x. Well, same thing for x plus h. Plug in an x plus h everywhere there's an x. Minus the whole function all over h. Once you plug into this formula, and don't forget parentheses around the function. I can't tell you how many times I see students make that mistake. It's minus the whole function, not just the first term. Once you get this into the limit formula, it's a limit problem. Okay? So if you're not familiar with limits, you're going to be in trouble. So you need to go back and review limits and know them backwards and forwards if you're going to be trying to do the definition of the derivative. Otherwise, it won't work. Okay? So go back and review if you need to, but I think just doing a few of these would be the best way to approach this, so I'm not going to harp too much on this anymore. Practice, practice, practice. Check out the beginner, intermediate, and example videos, as always. And thank you, and have a nice day.